Hi everyone, my name is Kingsley Idoko and I want to welcome you to another session on the series for Juniper SRX devices. And of course, our focus is working on implementation of clustering for the SRX device. Okay, so this is like the fifth video on this series. So if you've not watched the first four sections of the video, you might want to go back because this video is going to be built on what we've already discussed and also implemented. And of course, if you like this video, you want to subscribe and like and also share with your friends. Thank you. So walking through what we've done before now is that these two devices, which is this primary and the secondary device, they are part of a cluster, right? So we've added them to a cluster. We've set up the control link, we've set up the fabric link, right? And then we've also configured the LAN interfaces, right? So we took these two interfaces, we'll put them in a direct interface, right? And then we tied it to a redundancy group, right? So in this case, redundancy group 1. So we did the same thing for the one link, right? So we took these two links, we put it in a direct interface, and then we also tied it to redundancy group 1. Okay, so this is our node 0 and this is our node 1. Okay, and then we also went ahead to configure, of course, our zones. We created zones, we tied the various direct interface to the zones, then we created policies. Policies defines what the traffic that is allowed between zones. And then we also implemented source NAT, right? So source NAT is what allows these servers to, go through this device to the internet. And so we tested that and we were able to ping the 8.8.8. Same for the second server. It's also able to ping the 8.8.8. Of course, I don't have to write it twice. Okay, so that is what we've done so far. That's what we've been able to achieve. So in this section, we want to start testing, really. Okay, and then of course there's still some few things that we need to implement. Like for example, we will look at a situation where we want to take these interfaces and tie it to LECP, right? Because you could, in the end, you could have multiple connections, and then you want to like bundle these connections, right? Both for the LAN and the one link. So we've not looked at that. It's something we can maybe during our testing, probably in the next video, we'll just quickly put that in, where you see how you can actually take these direct interfaces and then bundle them with the switch. So at the switch level, you are running basically your LECP port channels, but on the Arista, on the Juniper SRX device, you see how we can actually tie direct interface to LECP. But that's not the focus of this video. In this video, we want to start looking at failover, right? Failover. Now, the way failover is implemented in Juniper is quite a little bit not as simple as the Cisco, right? Because of the whole idea of a redundancy group. Okay, because here you have at least more than one redundancy group, and so failover happens per redundancy group. Now there are different ways of doing failover. You have the manual method, right? So there's the manual method, right? And then there is the automatic method. Okay, so by automatic, you already should know what that is. So manual method means you and I, we are network engineers or network security engineers, and then we want to move traffic from node 0 to node 1, right? maybe these cables are bad, maybe you're having packet loss, you need to do some cable cleanup, change the SFPs, something like that. Or it could be that you want to upgrade, or you're having performance issues over the primary, so you just want to move the traffic away from the primary device to the secondary device, just to, you know, help you isolate what the issue is. Okay, so there are tens of reasons why you might want to do manual failover, but yes, it is possible to do manual failover. I think the command is very simple. It's set, I think it's request, request chassis cluster, then you specify the redundancy group, right? Redundancy group. So in this case, let's say we are dealing with redundancy group 0, right? It's not written there. Redundancy group 0, and then you say I want to move it from node 0 to node 1. Okay, so this is our node 0 here, and then we are moving it to node 1. So this is the command to actually initiate that failover. Okay, I believe you should be able to do it on any of the device. It doesn't have to be on the primary. I believe you should be able to do it, run the command from any of the device, and it will initiate the failover, right? We'll test that. Maybe we'll test it if it's possible to do it on the secondary and the others, but I believe you should be able to do it from any of the device, and you failover traffic. Then of course the automatic way, like we said, okay, we've not talked about automatic. Now this could be different reasons. So this is automatic, so the devices do the failover on their own. It could be any reason. So let's say there's a loss of power, right? So that is like a hardware issue. Or it could be that there's a bug in the operating system. The operating system crashed, and so the node 1 is not able to receive heartbeats from the primary. Okay, so it could be hardware or software related issue. Okay, then other triggers could be like it could also be like memory issues on the device, you know, right? Then you could also be, if you're monitoring the physical interface, which we will talk about in depth maybe in this video or later. We can also monitor physical interface. So if the physical interface goes down, right, so this up/down, okay, we're going to monitor those interfaces, and we're going to set weight on them. And then, so if there's a weight and the global tolerance threshold is 255 and the port goes down, it can also cause the failover, automatic failover of traffic from the primary, or from node 0 to node 1. Okay, so let's dive deep a little into this failover, the manual failover that we just talked about. Now, so like I said, we initiate the traffic failover, right? Now, whenever you are doing a failover, let's say you and I want to do a failover from the primary, from node 0 to node 1, then you have to take note that there's something we call the hold down time. Okay, hold down interval or something, right? Interval, or you can call it time, right? It's basically a time, okay? And that hold down time, what it does is this. So the moment you fail traffic, in this case, let's say we are referring to redundancy group 0, right? So let's say you fail traffic from the primary to the secondary, from the 0 to node 1. Now, on this primary, this device that will move the traffic is going to immediately start a countdown for the hold down time. Now, for redundancy group 0, the default value is 300 seconds. Okay, so this timer kicks in, and then it starts counting down, right, for 5 minutes. So what that means is that if you fail traffic back to node 1, right, you know node 1 becomes primary, right, becomes primary. Okay, but this node 0 is going to start a hold on time, right? It's going to be secondary, but it's going to start a hold on time. What that means is until this hold on time expires, the two devices will not be ready. Ready means they can no longer do another failover. Okay, so there could be situations whereby you move traffic from node 0 to node 1 and maybe it's not working. Okay, and you maybe you want to quickly roll back to node 0. You won't be able to do that until this timer expires, and 5 minutes is the default, but the range I believe is between 1 seconds up to 1800 seconds. Okay, so I think 1800 is like 30 minutes. Okay, so it means for that period, right, if you set it to like the 1800, you won't be able to fill traffic back to the device that was originally the primary, which in this case is our node 0. Okay, so this hold down time is always there. You have to take note of that. So it also same applies to redundancy group 1. Okay, so let's say these are interfaces are redundancy group 1. So let's say, for example, you have a flap here, right? And like I said, let's say we are monitoring the interfaces and they have their weight, which we'll talk about, right? So when interface flaps goes down, right, it can cause failover for redundancy group 1. Okay, so when it fails and it causes the automatic failover, which is something we will talk about, right? Then the hold on time also kicks in. But the difference between that of the redundancy group 0 and 1 is that the default timer for other redundancy group except the 0 is that it is just 1 second. So the moment there's the failover, or you do a manual failover, or whatever the reasons, there's also a default hold on time of 1 second. So it means within that 1 second, which is really short, right? 1000 milliseconds, right? You won't be able to fill back to the primary. So that is that for hold on time. It's present across all redundancy group, but it's really very critical for the redundancy group 0. Now, one thing I want to mention is, remember the redundancy group 0 is where you have your routing engines, right? Your ROE. So there are a lot of processes that run. So if this device is primary for redundancy group 0, now there are tens of processes that are running. And so when you do a failover from redundancy from node 0 to node 1, then all those processes relating to the clustering and that makes it the primary are going to be stopped. In fact, they are going to be killed, right? And then they are going to be spun up on the new device that will take up the role as the primary. So there's a lot of things that goes on between both devices when you do failover for the redundancy group 0, because that is where you have your routing engine, that's where you have your routes, that's where you have your routing tables. So there's a lot that goes on. So as network engineers or as network administrator, we want to be careful when we move traffic for redundancy group 0 between the two clusters, because it could lead to packet loss of state, or even degraded performance, right? These servers could experience packet loss, right? And you could have escalations or from your users. So that is why that what Juniper really allows to what is allowed in redundancy group 0 is mostly the manual method, right, where the administrator is actually in control. Automatic failover for redundancy group 0 exists, but it's usually when there's like a hardware failure, maybe the primary reboots, right? Yeah, so we're going to talk more about it so that we don't end up missing every single point altogether. Okay, so that is really all we need to know about the manual method, right? That we are the one initiating it, and the question is, if you have two redundancy group, which is redundancy group 0 and redundancy group 1, how would you handle that? Because you want to move traffic from the primary from node 0 to node 1. First, what you want to do is, of course, move the control plane, right, which is redundancy group 0. You want to move it from the primary to the secondary, and you want to make sure that everything is stabilized, that all the processes are running, that the primary, the node 1 has actually take up the role and it's at that state code ready, right? Then before you then go ahead and move redundancy group 1 from the primary to the secondary device. Okay, that will be the best way to implement, because if you look at the previous video that we did towards the end, what we did was that we moved redundancy group 0 from the primary to the secondary, and within a minute we tried to also move redundancy group 1, and what it led to issues, right? What happened? We started having packet loss, right? In fact, it wasn't packet loss, it was a complete outage. The servers could not reach the internet. It's because the way we initiated the failover is not wasn't the best way, right? When you move redundancy group 0, you want to give the device time to stabilize, ensure the processes are running and it's in a ready state, then before you go ahead and to move the other redundancy group. Okay, so that is that for the redundancy group 0. Then something else we need to talk about now is just trying to be sure we don't miss things out. So let's talk about the automatic failover now, right? So for the automatic failover, let me put it here. For the automatic failover, so this could be just like we said, when there's a hardware failure, right? There's loss of power. Okay, so when there's loss of power, two things happens. On the control link, you saw the second device stop receiving heartbeats, right? The fabric link too, it goes down, right? So the moment the second receives that, oh, here it's down, here it's down, what does it do? It means something is obviously wrong with the primary device. So it immediately transitions from secondary down to primary, right? For all the redundancy groups. Okay, in this case, because you know the primary is no longer there, we are no longer receiving heartbeats from there. Also for redundancy, for interfaces, if there's a flap, okay, so in our own case here, this interface is in redundancy group 1 and this is a rect interface. Okay, so if we are doing monitoring for these interfaces and it goes down, right, because depend on the let me just clean there. So let's say here we set the weight of 255, right, for monitoring of the interface. So here we set 255, here we set 255, and here we set a weight of 255, and the entire node itself has a tolerance weight of what? Of 255. Okay, 255. That's the default value. So what that means is, if this port should go down, we're going to take this 255 and minus it from the global value, which in this case gives us 0. So the moment the threshold is 0, right? The moment the threshold is 0, is going to force this device to fail over from the node 0 down to node 1 for that redundancy group. So in our case here, we are referring to redundancy group 1. Okay, the traffic is going to fail because there's a port failure. That actually makes sense, right? Because if this port interface goes down, then traffic cannot really go through the device. Okay, so when you are doing interface monitoring, which is something we will implement probably in the next video, you are going to see that yes, this is one of the triggers that can cause the automatic failover. Then of course, if this device power cycles, just like we said, or there's a memory issue, or there's a bug somewhere, it can result in automatic failover. Now, something else I want to quickly talk about also is this. So let's say this device power cycles, right? It's primary both for redundancy group 0 and redundancy group 1. This is our node 0, this is our node 1. Okay, so let's say this device power cycles. So the moment it power cycles, the secondary device, which is node 1, becomes primary for both redundancy, right? So it's primary for redundancy group 0, it becomes primary for redundancy group 1. Okay, because we've lost the primary. Now the question is, what happens when it comes back up? Okay, so when it comes back up, okay, what is going to happen is this. If we don't configure preempt on the redundancy group, when the device comes back up, it's not going to take back the row of primary. It's not going to be acting as secondary for both or for the two redundancy group. Okay, because no preempt. So even if the configuration say, oh, you have higher priority actually, right? Your priority here is 200, but here you are 100. So long preempt is not tied to the redundancy group, there will not be it will not take back that responsibility of being the primary device. Okay, now preempt is not even allowed for redundancy group 0. Okay, so what that means is if this device should reboot for any reason and redundancy group 0 and the node 1 becomes the primary, right, for redundancy group 0, it's going to stay that way when it comes back up. So whether there is because preempt is not allowed for redundancy group 0. Okay, because like we said, redundancy group 0 is a very critical redundancy group. It's not even advisable to add data ports. So these interfaces is not advisable to tie to redundancy group 0 and then you are monitoring. Otherwise, you're just going to be having outages, especially when there's issues on those ports. So it's advisable to move these physical ports away from redundancy group 0 to any other redundancy group, right? Then, but of course, you can move the control link and the fabric link. They're always going to be there because they are part of the control plane. Okay, so preempt is not allowed for redundancy group 0, but preempt is allowed for redundancy any other redundancy group. So some devices allow you to create redundancy group from 1 up to I think 128. I think virtual XROS only allow up to 663, I think. I don't know. Okay, so for every other redundancy group you can configure preempt. So now since we've established that it's not possible to do it on redundancy group 0, let's go to redundancy group 1 and then let's see what happens. So let's say we are now looking at redundancy group 1. Okay, so this device power cycles, right? So if for redundancy group 1 there's a preempt, okay, and here has a higher priority of 200, right? 200, and here has a priority of 100. So when it power cycles, this box becomes the primary, okay, but as soon as it comes back up, okay, as soon as it comes back up, then because the preempt is enabled, it's going to take back the row. Okay, so what you end up seeing is that yes, he was primary when this was rebooting, but as soon as it's back up, then it takes back the row of the primary. So under preempt, there's still some other enhancements. There's something we call the preempt delay timer. Okay, there is preempt limit. These values, I think this is in seconds, right? Then there's a preempt period. Okay, so limit has to do with count. Period is also a timer. Okay, now what are these? Now for the delay, I think delay applies to, let's say this device is secondary, right? How long should it wait before it transitions from the secondary to primary when there is a failover? Okay, so take for example this port flaps, right? It goes down. How long should this device wait before it transitions from the secondary to primary? So that is really what this delay timer is. So why preempt is there, which is what we cause the failover, right? But how long should it wait for that to happen? Now, what's the reason for the delay timer? Now let's look at it this way. Remember we talked about the hold down timer. We still have that, right? And we said for redundancy group 1, the value is 1 second. Okay, so let's say it's 1 second that we have. Okay, let me delete this. So this port flaps, hold down timer kicks in, 1 second expires, and then what happens? There's a failover, right? Then the traffic moves to this device. Okay. Then within 1 minute again, the port is back up, right? Comes back up. Okay. So what happens? Because there's preempt, the traffic goes back to this device. And then after 3 minutes, it goes down. Then it fails over, and then you can have these endless cycles of traffic steering between the two devices. So that's where the delay timer actually comes. It's just a way of ensuring more stability. And the whole idea is this: if this port flaps, right, how long should this device wait before it actually proceed to transition from secondary to primary, right? I think the default value is between 1 second, right, up to 21,600 seconds. Okay, so you can see, let's wait for 30 minutes. Okay, you say, oh, if this port flaps, don't just go ahead and fail over as primary, right? Let's add a delay of 30 minutes. Well, you might say that doesn't really make any sense, right? Because you have a traffic going through this part and this port goes down and you have a delay, right? So it's definitely going to impact traffic. But you can also look at it from the other way around and say, okay, let's say this port flaps and there's a failover to the secondary, and then it comes back up, right? So it's up again. You don't want to go ahead and fail back immediately because there's a delay timer. So even if the port is flapping, it keeps flapping, once the traffic moves to the secondary, it's going to remain there for a while. So it's really a way of improving stability between the two nodes. That's the whole idea of the delay timer. Now, where does the limit count comes in? The limit count is saying what is the total number of failover that is allowed before you disable preempt, right? Because this is endless cycle, right? So you want to say, oh, by the time you have 10 failovers, right, within 30 minutes, right, you are saying within 30 minutes or within 300 seconds, if you have 10 failover count, go ahead and disable preempt. It's not really disable preempt. You have to reset the count. It stops the failover because obviously the system is not stable. Okay, so this 30 minutes here apply to the period, right? While the 10 applies to the limit count. Okay, so you can say, oh, if you have 5 failover within 300 seconds, then go ahead and stop the failover. Okay, and once that failover is stopped, then you have to manually reset it for it to start all over again. Now you could have situations. So let me give you an example. Let's say we configure the limit as 10 failovers, right? And then we set the period as 300 seconds. Okay, so what that means is if within 5 minutes you reach this value, that's when the failover is paused or stopped, right? Or you have to manually reset. Now let's say within these 300 seconds you only got up to 8 failovers, so you didn't reach this threshold of 10. So what that happened is the 300 seconds has expired. It's going to start all over again from 300 again and start cutting down, right? 300, 299, all the way down. But what happens to this value? This value itself was also have to start back from 0, right? So once the period expire, the limit count also gets reset. Okay, so if you were count 8 and your 300 seconds has expired, then you have to start all over again back from 0, then start your 300 seconds. Okay, so just take note of that. So these are really enhancements to preempt to ensure that there's better stability within the cluster. Now the last thing we want to quickly talk about is the device state. Okay, now you know that this device can be primary. Okay, it can also be secondary. right? Then for the secondary, it can also be primary. It can also be secondary, right? Now there's another state called the ineligible state. Ineligible state. Then of course, you also have the disabled state. Now we are very familiar with primary and secondary, right? But what is ineligible state and what is disabled state? Now for the ineligible state, what happens is this. So let's say you have the control plane, which is this link, right? Remember, I don't know if I said it before, there's a process called the Juniper SRX. It's the Juniper Service Redundancy Protocol. It's like the process that is actually, it's like the language of love between this device. So JSRPD is a process that runs between the two clusters. In fact, it's what is responsible for sending heartbeats back and forth between the two devices. Okay, so this will be here. Okay, so this JSRPD send heartbeat between these two devices over this control link. Now what happens if the secondary device, so this is a secondary device, what happens if it stops receiving heartbeat from the primary? Okay, so the moment it stops receiving heartbeats from the primary, it immediately goes into the ineligible state, right? You say, well, I don't really know what is going on, but somehow I think I have a problem with either the control link or there's a problem from the primary. So it goes into this ineligible state. Now, to verify if the control link is actually down, what it does is this process itself try to send the same heartbeat over the fabric link. You know, this is our fabric link. Now, if it is successful, if they are still receiving heartbeat over the fabric link, that actually tells the two devices that there's a problem with the control link. So they go ahead and so the secondary moves into what we call the disabled state. Okay. Now, when a device is in the disabled state, for you to bring it back to the secondary state or primary, you will require a reboot. Okay. So when the device is in the disabled state, you can still log in, you can still SSH into it, you can still check the configuration, but it just tells you that, oh, there's a problem with the control link. Okay. Then you might say, what happens if you can't get it on both sides? Well, that means the cluster is broken. Both devices will go into primary for their redundancy group, right? It means something is wrong somewhere. You don't want to have this kind of situation because you can have the two devices forwarding packet for both redundancy group, for the redundancy groups. Okay, but when only the control link is broken, but the fabric link is still going through, and the devices are still able to send heartbeat over the fabric link, that's when you have the disabled state. And so when the device goes into the disabled state and you're able to fix the control link, then all you need to do is to reboot the device that's in the disabled state. There's also a command called the cluster recovery. Cluster recovery. Okay. Now if this command is enabled, I think it's a global command. I don't think it's tied to any redundancy group. We'll look at it in the next section when we start actually testing all the things we've discussed. This cluster recovery, what it does is, the moment it detects that the device is in a disabled state, and maybe for some reason, maybe this port was actually flapping, it was down, and then after some time it comes back up, then this cluster recovery will see that, oh, this device is actually in disabled state, and it will automatically initiate the reboot to bring it back to secondary or primary, as the case may be. Okay, now when this device is going into a disabled state, the primary stays as primary. Okay, because from the fabric link they can still see that, oh, there's something, we can still talk to each other, right? So he remains as primary, but this device is in the disabled state. Now let us quickly cover the last part of this video. The question is, this device was primary, it goes down, or there's a power cycle, then this becomes primary. Let's say for redundancy group 1. Okay, Now when it comes back up, right, what happens is he is not going to automatically become primary. He will stay as secondary first. Then he's going to look at his configuration, check preempt is enabled. Yeah, okay, means I can preempt the primary. Then he's also going to look at, of course, priority. Even before the preempt, priority says, oh, I'm 200 and you are 100. Okay, so priority says, oh, you should actually do the preempt because I have higher priority. Okay, now he's going to check, is preempt enabled? Yes. So since preempt is enabled, he's going to try to preempt, take back the role of the primary, right? Now he's also going to check, is there a delay timer set? Remember we talked about the delay timer before. So if there's a delay, then what happens is he's going to transition, right, from the primary hold down state to what we call, from the primary, it's going to move to what we call the primary hold state. Okay, so it's going to remain in this state for the configured timer, delay timer. Okay, now once the timer expires, that's when it goes into the secondary hold. Okay, and then before it becomes secondary. Okay, so this also further explains the reason why you have the delay timer, that when a device comes back up, does not just automatically becomes primary. It has to go through these delays, right? Go from the primary to primarily hold state, go to the secondary hold state, then before eventually becoming the secondary. Okay, so now that we have I believe we've covered every aspect of this failover. What we now need to do is we need to log into those devices, and then we actually need to test some of these things we said. We are going to configure preempt, set the delay timers. We are going to do interface monitoring. We are going to see if we can force automatic failover. We're going to do reload. We are going to see how the devices behaves when there's a reload, how they take back their how preempt works, how they're able to take back their role. We're also going to look at we're going to see if it's possible to actually do monitor the interfaces, because of course we are in a virtual environment. Even when you shut this port down, this port could still be up, but we'll see what we can do with if it's possible to do those triggers through interface failures. Yeah, so those are things we'll talk about, and then if we still have much time, then we of course configure we'll just see how we can do LSCPs on this port. All right, thank you. So if you like this video, please subscribe and also share with your friends. Thank you, and see you in the next video. Bye.